Hi, in this short video, we will talk about squeezable user interface. What are they and how can we design them intelligently? A squeeze gesture is any pressure action exerted with or on a squeezable object, sometimes in combination with a motion of this object that causes a detectable form change of any part of it. They can take several forms such as stretching, pitching, folding, or pressing on an object. Some squeezable user interfaces are Boycon, a ball-shaped, soft and wireless controller which can be turned, rolled, squeezed, or moved to perform different tasks. Another example is Squeezy, which used in our research. It is a complete system for developing squeezable interface, including hardware to record deformation and software for recognizing squeezy gestures. After analyzing existing works on squeezy gesture, we realized that most of the research focuses on developing the technology for sensing and recognizing this gesture. However, little exploration has been done regarding how this gesture could be effectively designed and mapped to various tasks. Our research attempted to fill in this gap. Thus, we conducted a gesture elicitation study with 32 participants. We asked them to propose gesture with a squeezing-enabled cushion for 21 AIUT tasks, such as turning light on and off, controlling the TV, and answering the phone, and so on.
We also defined a taxonomy of squeeze gestures consisting of four main categories: 0D, 1D, 2D, and 3D. 0D gestures are limited to applying pressure on one or several points of the object, while 3D gestures can consist of any motion in space of the squeezable object, such as folding it. From our study, we identified a wide range of gestures, which we grouped by similarity. Tasks, such as turn TV on and turn TV off, resulted in a very high agreement between the participants, while other tasks, such as turn aircon on, mute, or unmute, had very low agreement. Depending on the task, gestures were applied on different parts of the cushion, such as turning the TV on or off, which the participants usually performed in the middle of the cushion. We also noticed that gestures disproportionately involved the top and right sides of the cushion compared to its center and bottom, which were less involved. From these results, we were able to draw a set of implications for designing squeeze user interfaces. For instance, developers should prefer to use push and fold gestures, which were the most frequently proposed gestures by the participants and are easier to perform and capture than the slightly less popular draw and swipe gestures. In addition, we noticed that when participants performed gestures using both hands, they were always symmetric. As such, we advise developers to prefer symmetric bimanual gestures instead of asymmetric ones. If you want more details about our research, including the full results and implications of our gesture elicitation study, consider reading our full paper. Thank you for watching.